In this video, we're going to be talking about relationships in a table. And the main TEK that we're going to be talking about is TEK 3.5e, which is representing real-world relationships using number pairs in a table and being able to describe those relationships with verbal descriptions. There are some TEKs that kind of support and go with this the main relationships in table TEK, and those are 3.5c, 3.4j, and 3.5d. So as we are working on relationships in a table, we may also describe those relationships using a multiplication expression as a comparison. We will also be finding quotients and be determining the unknown whole number in a multiplication or division equation. So those last three TEKs there aren't specifically what we're working on in the next few days, but will be embedded into what we are doing. As you see on the instructional talk page, this is students' first understanding or first introduction to relationships in a table. So the instruction you give for this will have to be more direct, guided instruction from you. So the very first day of the progression says that we're going to start out with concrete materials to find and create tables. So I would start off pretty simply. One of the things that we recommend is using the pattern blocks. So I may say, if I want to know, so one block has how many sides? And so you're going to start off simple with kids like this. One block has how many sides? So one hexagon has 6 sides, right? So what if I have 2 hexagons? 2 hexagons, 6 plus 6 is 12. 3 hexagons, 6 plus 6 plus 6 is 18. And so forth, and you can continue the table with that. Then, after you've kind of done a little bit of the table with them, you can then ask them, well, what if I had 6 hexagons? How could you figure out how many sides would be on 6 hexagons? And you're going to lead kids to thinking about this relationship between the block and the number of sides. When you're working with kids, I usually tell them that there is a magic column, something that's happening to the 1 that gives them the 6, something that's happening to the 2 that gives them the 12. And so we work on thinking through this magic column, and I may ask kids, so what did I do to 1 to get 6? Well, they may tell me they added 5. Okay, well, that would work. What else could we do? Well, we could multiply 6. Perfect. So, whatever the relationship is, and it's very important for kids to understand this, whatever the relationship is, it has to work for every single number. So, if I have 2 blocks, if I added 5, which was the first rule that they told me, I would get 7 and not 12. So this plus 5 cannot be the rule. But can I do 2 times 6? Is 2 times 6 12? Yes. 3 times 6 is 18. So that means that 6 times 6 would give me the number of sides, which is 36, right? So then I may want to do something like, well, what if I had 48 sides? Could I figure out how many blocks we would use, or how many hexagons we would use? It's important to make sure that students look at tables from left to right, but also from right to left as well, okay? I can also say that the number of sides is 6 times as much as the number of blocks. So I can use those verbal descriptions while I'm working on my table as well, okay? I also think it's important for you to note that all tables do not have to start with 1, and they all do not go sequential in order. I may start a table, it may start at 5, and the next number may be 8, and the next number may be 10. So don't just give students tables that start with 1 every single time. Okay? All right, so you do want to do addition, subtraction, multiplication, division tables. You can use concrete items like this. When I first started, when we did patterns and tables, I would always bring in items like a 6-pack of Coke, and we'd talk about 1 6-pack had 6 Cokes. Any kind you bring in, kind of like a prop, and use that prop to find the relationship, I think it's really helpful for students to see kind of that real-world application of why I would use tables. After we give them a couple of days using blocks or making tables, we are then going to, of course, look at tables. Make sure I get this straight. Of course, we're then going to start giving them tables like this. We may have them do a scoot. We may have them do a gallery walk where they go around and they try to find whatever the missing number is in the table. So for this, the first thing that I have to do is I have to draw my magic column, because I know that I'm looking for a relationship between the number of booths and the number of bags of candy. So once again, you talk to students and say, what did I do to 5 to get 15? And once again, they could say add 10, and they could say multiply 3. So in the next column, we're going to add 10 first. Is 7 plus 10 21? No. So of course, that's not our rule. Is 7 times 3 21? Yes. Is 9 times 3 27? Yes. And I would make them label this table all the way down. And so in this column, what I see is a number times 3 should equal 36. So to be able to find the number, you have to have students understand that if I'm moving right to left in a table, I'm doing the opposite operation or the inverse operation. So to find out the answer, I can do 36 divided by 3, or I could do a blank times 3 equals 36. Okay, so that's how you, that is the strategy. It's how you teach kids to look at tables. Sometimes they may have to extend the table. Sometimes they're just looking for a missing input or a missing output. Sometimes they ask about the relationship. What is the relationship in the table? As I said, make sure you do all operations for patterns and tables. Don't leave any out, because they could get an addition scenario. They could get a subtraction scenario as well. All right, I think that's it for patterns and tables or relationships in a table. If you have any questions, please let me know.